All right, so we just had a really long vocab video. Let's see if we can shorten one up a little bit, but we're gonna keep using the vocab we just learned. So it's good to keep using this so that we actually learn these words. So we're gonna relate central angles to their arc measures. So it says, when we put this M in front, remember that's the measure of arc AB and the measure of arc ACB. So the measure of arc AB, remember, we go from A, we find the quickest path to B. This is going to be, if we're using two letters, it's a minor arc. I know that's less than a semicircle, so it will be less than 180 degrees. So let's just make a note. Angle APB is the central angle. And we put in our vocab that the central angle and the arc that it intercepts. So I follow this angle out, it hits the circle here. I follow this angle out, it hits the circle here. It's creating arc AB. Well, arc AB is going to have the same measure as the central angle. So I know that the measure of arc AB is equal to 95 degrees. All right, great. Now they want us to find the measure of arc ACB. So if we look at the picture, ACB, let's just trace that from A to C to B. So they use three letters, so it's going to be a major arc. We can see that is bigger than a semicircle, which is half the circle. So it's going to be bigger than 180 degrees. So how do we figure this out? Well, pretty much we just are looking at the rest of the circle, right? Arc AB is 95 degrees. We want to know what arc ACB is. The whole thing measures 360 degrees. So to get the measure of arc ACB, we just take the full circle, 360, and let's subtract out the one we don't want. Let's subtract out that 95. That leaves us with 265 degrees for the measure of arc ACB. Seems okay, right? All right, so let's just try another quick one. What are the measure of arc XZ? So if we look at the picture, we're going to trace from X to Z, minor arc. So the measure of arc XZ is going to have the same measure as its central angle, the angle at the vertex. So we can see this angle comes out, hits Z, comes out, hits X. Say 115 degree angle, which means the arc is also 115 degrees. All right, how about the measure of arc XYZ? So if we trace from X, we're going to go through Y, come all the way around to hit Z. That is essentially the rest of the circle. So this is going to be 360 minus the 115 that we figured out arc XZ was. And the measure of arc XYZ is 245 degrees. All right, so last we just have something to write in about arc measure. The arc measure will be equal to the central angle measures. So in this picture over here, we can see we have arc JM. So the measure of arc JM will be equal to the measure of its central angle. So if I follow JM in, it gives me this angle right here, JPM. All right, if you have congruent central angles, so if we look at the picture, central angles are at the vertex. I have these two angles right here that are marked congruent. That means that their intercepted arcs will also be congruent. So in this picture, what we're saying is that if the angle JPK, so JPK is this first one right here, if that's equal to angle KPL, so KPL, that's this angle. If those two angles are congruent, then that means that the intercepted arc, so where those angles come out and hit the circle, this intercepted arc is equal to this intercepted arc. So we would say that means that arc JK is equal to arc KL.